Hello everyone, welcome back to another lesson. While watching these videos, please keep something to write with and your classwork books nearby. This will make it easier for you to take notes, write down interesting thoughts, and therefore have a better lesson. And perhaps, most importantly, although classes have been indefinitely suspended, learning never stops. Let's rock! In the last video, I asked you a few questions. However, I did not provide the answers. Right now, I will give you the answers to those questions. First, let's quickly go over what they were. The first question was, if an incandescent light bulb burns for 1000 kilowatt hours, how much energy is given off as heat? If you remember, about 90% of the energy given off by an incandescent light bulb is heat. Therefore, 90% of 1000 is 900. The answer is about 900 kilowatts will be given off as heat. Question number 2. If a fluorescent light bulb burns for 1000 kilowatt hours, how much energy is given off as heat? Again, if you remember correctly, about 25% of the energy given off by a fluorescent light bulb is heat. Therefore, 25% of 1000, and that is 250. The answer is about 250 kilowatts are given off as heat. Question number 3. Which bulb produces more light in the same amount of time? The energy given off by each light bulb can be divided into two categories. One is heat and the other is light. Therefore, if 90% of the energy given off by an incandescent light bulb is heat, that means there is only 10% left that will be given off as light. Conversely, if 25% of the energy given off by a fluorescent light bulb is heat, that means 75% of the energy given off by a fluorescent light bulb is light. Therefore, a fluorescent light bulb produces more light in the same amount of time. We also already talked about electric force. Charged objects can attract or repel each other depending on whether they have the same charge or a different charge. Let's see some examples of charges in action. Oh no, look at this cat. He has a pink balloon stuck to it. How did that happen? Well, the balloon was rubbed against the cat's fur, and this caused some of the charges from the balloon to flow to the cat. Therefore, perhaps now the balloon has a negative charge, and maybe the cat has a positive charge. Therefore, the balloon is attracted or pulled towards the cat. But I do not think this cat is happy, and maybe this is not a very nice thing to do. So now this guy is walking around in the middle of winter on a carpet or a rug at home. And what happens is the friction between his feet and the rug allows some of the charges from the rug or the floor to flow up into his body. These charges build up and up and up and up and up and collect in his body. Then, when he touches something metallic or something that is a good conductor, for example, a doorknob, ow, maybe he will get shocked. Why? Because suddenly the electrical charges that built up in his body found an easy path through which they can flow, and when they flow out, you might experience a small electric shock. In this picture, does the pink balloon have a positive or a negative charge? And how can you tell? Well, if you look carefully, you will see that the pink balloon has a total of 5 charges. 2 are negative and 3 are positive. Therefore, overall, the pink balloon has a positive charge. What about the green balloon? Look carefully. The green balloon also has a total of 5 charges. However, 3 of them are negative charges and 2 are positive charges. That means the green balloon has a negative charge. So looking back, the pink balloon has a positive charge and the green balloon has a negative charge. What will happen if two objects have different charges and they are near to each other? They will attract each other. Do you remember what would happen if the two objects had a similar charge? For example, they both had a positive charge or they both had a negative charge? They would repel or push each other away. Whoa, what happened to this boy's hair? Well, as he slid down the slide, his hair and his body became positively charged as charges from the slide went into his body. Now, because the individual strands of hair have the same kind of charge, they push away from each other, and that causes them to stand up and spread out. It looks quite funny, don't you think? How electrical energy is released. Charged particles move. This movement of charged particles releases electrical energy. Small shocks. You observe a release of electrical energy when you feel a shock from a doorknob. You drag your feet on the carpet. Negative particles move from the carpet to you. This causes you to have a negative charge. When you reach for a metal doorknob, the negative particles move from you to the doorknob. Electrical energy is therefore released, and you feel that electrical energy as a shock. Oh no. Thank you very much for watching this video. I hope it was useful, and I hope you learned something. Remember, we don't have face-to-face classes these days, but learning never stops. Take care and see you next time. Goodbye.